Yeah, I just want to say thank you to Ben and William for having this thing set up. It was a really, really good opportunity to be able to come in and actually do some conference style presentations. I've done speaking before. I've done lots of stuff regarding teaching. I've spoken at our local user group, but I've never done any sort of conference speaking. I've been in this space for about 10 years. I'm mostly on the business intelligence side, so less on SQL Server, less on when it comes to say operational performance tuning, and I've done a lot of work with ETL, data engineering, moving data from point A to point B, and organizing it so that you can make analytical decisions based off of that. But that's not all I am. Like I was saying a little bit before, I'm a rower. I do a lot of mountain bike. I've got a couple of kids that I play around with. I've got my links in the presentation. I'm going to toss this presentation and the Power BI file that I'll be using throughout this is up on my GitHub, and I'll toss that into the chat in a little bit, so that anybody can download this and look at the Power BI file that we're using here. So what are we going to talk about today? There's been a number of sessions within New Stars of Data here on Power BI. I just went and counted them. It looks like there were about 7 of them. One thing that I find is missing or not always covered as much is the actual foundations of Power BI. What is it? Why do we use it? What is it good at? What are the constraints that it puts onto us? And what are the choices that we need to make because of those constraints? So that's really one of the ways that I like to structure introducing folks to Power BI. And this is titled a talk for DBAs, because I want people to have a little bit of technical knowledge coming into this, knowing what data is, how it's kind of structured, and how Power BI, or more specifically the Vertipaq Engine, which is used by a couple of different products, changes how data is actually used. So I'm going to spend 15, 20 minutes talking about the constraints and underlying design choices for Power BI. Then I'm going to talk about various data architectures, either for transactional systems or data warehouses, or how analysts have done a lot of this type of work traditionally. And then what is the optimal choices for Power BI or for the Vertipaq Engine. And then lastly, we're going to talk briefly about some visual techniques that you can use. They're very easy to implement. They're very easy to understand why you would do these things. But if you follow a little bit of foundational guides, it's going to make your reports very useful. I'm not a designer. By no means am I a designer. I'm not great at making things look good visually. I know enough to be dangerous, and sometimes that's the worst place to be, but I know enough to make it useful. And in my opinion, if your reports get used, that is going to be the most valuable thing for your organizations. You could have the prettiest report out there, and if it doesn't get used, who cares, really? So let's talk about the constraints first. Power BI was originally designed, the Vertipaq Engine, which is underlying Power BI, was designed in 2006 by some of the SQL Server reporting services team. They wanted to use analysis services in an in-memory way to make various decisions. They were doing a lot of similar things within reporting services, and they wanted to make an engine that was optimal for handling the most common scenarios that these guys were finding in analytical situations. And the 3 things that they were finding is they want to filter large data sets. It's pretty simple to state, but there's only a couple of ways to do that efficiently. They want to aggregate on top of those data sets. Aggregation is really important when it comes to Power BI because it will guide one of those design choices that we need to make a little bit down the road. So I'll get to that in a second. But one of the primary use cases is aggregating over top of our data. And lastly, one of the things that's challenging to understand, but we want to capture the context that we're looking at and manipulate how a calculation is performed. So this is really easy to understand when you think about a pivot table. If I'm looking at a pivot table and I've got rows and columns on that pivot table, let's say my columns are various calendar years, and let's say my rows are various products. Each one of the cells that exists within that pivot table is going to have two pieces of context. The column context that is provided, that's going to be the year. And I have the row context, not the same as Power BI row context, but the row context in this instance is going to be a specific product. So I want to do a specific aggregation on a year and on a product. And I need to do that for each and every cell that is performed. So oftentimes when you were doing this traditionally and you had to do some pretty complicated Excel formulas, it took a long time for these types of reports to run. So anyways, they designed the Vertipaq engine to be able to do this type of work very fast. So what is the Vertipaq engine? It's a columnar database is really what it all boils down to, but it makes specific design choices for us in order to do those three things that I showed on the previous slide: filtering, aggregating, and capturing context and manipulating how a calculation is performed. This is done within three main tools right now. So Power BI and all of its forms. So Power BI on the desktop. The premium version is a little bit different, a little like analysis services kind of supercharged. There's analysis services in the tabular format that uses the Vertipaq engine. And then there's Power Pivot, which exists within Excel. I think it was actually introduced originally in 2009 as an Excel add-in, and then tabular services came in 2012. So what is a columnar database or a column store database? Basically, what it does is traditionally, when you have a row store database, each of the rows and all the values in those rows are stored on the same 8K pages in SQL Server. So, for example, on the left-hand side, let me grab my laser pointer over here. On the left-hand side, I have my ID number 1, I've got camcorder, I've got red, I've got a unit price of 112. All that information will be stored next to each other in that 8K page. The way a column store database works is it kind of flips that information on its side and says, okay, all my IDs are going to be stored together on the same page. All my names are stored together on the same page. All my colors are stored on the same page. And all my unit prices are stored on the same page. But the most important thing is that these are all stored in the same order. And that order is really what determines which rows I'm looking at. So I want the 50th row. I need to go to each and every one of those columns and find the 50th row, and it's going to give me the entire value. This isn't the only thing that our column store database does. There's also some very important implications with compression and how data gets compressed within the Vertipaq engine. So there's two main forms that take place. One is called value encoding. So on the left-hand side, this is how the value encoding largely works. And all of this stuff is from the Microsoft Press Store. So I've got links in here to those articles. So again, if you want to get access to these links, I'm going to have this presentation posted so you can all access all this stuff. What happens is on the left-hand side here, if we had our unit price, you can see the largest value in here is this 216. In order to store the number 216, we would need 8 bits to store that value. But we can reduce that because there's not too much of breadth of data. The span of data goes from 194 to 116. So this is only a difference of 22 values. So if we just store 22 values, which is 5 bits per row, and then we store a unit value of 194 and just say everything is 194 plus whatever that unit value is, I can store a lot more data in significantly less space. There's also, if we're doing calculations on top of this, where we need to sum that type of value up or multiply it across, there's also some really good algebraic functions that get implemented, allowing us to do those types of calculations quite fast as well. So that's largely what happens when we use numerical values. On non-numeric values, what happens is it gets replaced with dictionary encoding, kind of like hash tables, where we have just a single value, and then all of the numbers are what is actually stored. So in this case, I have 4 different colors. I store each of those strings once, and then I store an ID associated with those strings. There's only 4. I can store each of these values in 2 bits of data. So then I could have a very long column of just 2 bits of data. So it's very efficient to compress that size. And then on top of that, there's also run length encoding. And this is why the order that your data gets stored in is so important. You don't have to worry about any of this stuff. Power BI, the Vertipaq engine, does a lot of this work for you. There's a little bit of tweaking that you can do when you use some external tools, or when you use analysis services tabular mode, or you use the XMLA endpoint in Power BI Premium. But largely, this is done for you. It's automatic. You probably don't need to spend all that much time optimizing this until you get extremely large models. But what run length encoding does is it just says, okay, if I have repeated values over and over and over again, rather than storing each of those values in a big long column, all I'm going to store is the value that I'm looking at, which row it started at, and how many of them there are. Now, it doesn't, if there's repeated values, so we can have repeated values. So maybe it's not the most efficient to store that table by Q1, Q2, Q3, Q4. If I might need to do Q1 and then Q2 and then Q4 and then back to Q1 and then Q3, but it's still going to do better compression than just storing my quarters in one big long column. So if we put these two things together, let's see what happens. If I have a column, lots of values, it's going to first in dictionary encode those values. So I have one table right here in the middle here that stores each of the string values that I use for my data set. And then I just have the ID. This is all that's needed. It's 2 bits of data there. And then that then gets stored as run length encoding. So I've got these 2 tiny little tables that represent the 1,000 rows that is in my underlying data set. Again, this makes it very efficient from a compression standpoint. There's one other thing that happens when we create models, and it's very important that you end up creating relationships between your tables. We're going to get into how to design these in a little bit, but one of the big things is we have sales tables. These are more for describing our business events. They're called fact tables within dimensional modeling. And then we have dimension tables, which is all the descriptors of those business events. And when you create a relationship between these two tables, what's going to happen is you're going to have this intermediary table that gets created automatically behind the scenes. You don't have any control over it, that says this row is related to that row. Kind of like creating an index on foreign keys is really what that boils down to. But one of the other things that happens is if you have key mismatches, you're going to see here on rows 4 and 5, or sorry, product key 4 and 5 in the sales tables, those don't exist in my product table. So when you have key misses in this case, it's going to automatically create this blank row that no data exists. It's going to have the value blank. It's going to be displayed as blank. But that will get a row number in our relationship table. So you can see here down at the bottom, our sales product key is the key 4 and 5 is associated with row 4 and 5 in the product table. So if you're looking at some efficiencies, it's actually really good to go in and find these key misses and go and add them in and make sure that there's some referential integrity within your models. Power BI, the Vertipaq engine, is not going to do that work for you. So that's largely how data is stored within the model here. What are the implications of that, though? Big thing is that the lower cardinality of a column, so by cardinality I mean the diversity of data in that specific column. So in our quarter example, I had Q1, Q2, Q3, Q4. I have 4 different values that are in that table. If you have a smaller set of values, you're going to have more efficient queries. The other one is that data duplication isn't that big of a deal in the context of the Vertipaq engine. Now, I will say that if you have more duplication, it's actually going to be more efficient, especially in the context of your dimension tables, these tables that describe a specific business process. You can have duplication in there without any issues. When you have things like a fact table, a business event, if you have very unique values, those may not belong within this type of model. So I'm talking things like, and I have an example here where we're going to be looking at some purchase orders. My underlying model has comments on those purchase orders, but I don't bring the comments in. If I wanted to get the comments and understand the specific details of a purchase order, that's where you're going to want to use tools like paginated reports in Power BI, which is it's very similar to the old reporting services model. I can go in, I can specifically query if I have a row store database in that case, I can look up that specific row. It'll return the data very efficiently. And that's really one of the best use cases for that tool. It's really all about using the right tool for the right scenario. Power BI isn't the end-all be-all of analytics. There are a lot of use cases where it's not the best tool, specifically things like simulation and modeling. You can generate data in Power BI, but you shouldn't. It's not the best at doing that type of thing. And if you want to run over a big script of data or a script of steps, run that in some sort of Python notebook, do data science elsewhere. This is for doing operational analytics and making decisions based off of those. Another one of the implications is that relationships are based off of single columns between 2 tables. So you need to understand that when you're building out a model. So I can't have a type 2 slowly changing dimension where we're tracking the history unless I use a unique index or a surrogate key on each of those rows so that I have a single column with unique values between my 2 tables. And lastly on here, I'm talking about traversing relationships. It's an expensive operation. So what we want to do is that we need to minimize the number of relationships that we use in our models. Sorry, not in our models, but we want to minimize the number of relationships in a specific analytical query. I have an example that I can show you based off of that. This is a snowflake schema. And you can, let me just grab that laser pointer back here. So I've got my reseller sales. This is the table that I want to aggregate. It can be described by various products. Those products can be described by the various subcategories in it. Those subcategories can be described by various categories. This is pretty traditional when you think of things like third normal form or traditional Inman data warehousing. And it works fantastically for that use case. But within Power BI and within the Vertipaq engine, the way a query would happen on something like this, say I need to filter my categories a little bit and my subcategory and maybe one of the columns in my product table. What's going to happen in the underlying engine is first, it's going to go from the outside in. It's going to filter my category table. That category is going to give me a set of rows. Then it's going to go through this relationship, which again is another table. And it's going to filter that table to give me yet another set of rows in order to filter the subcategory. So I've got another filter that takes place. That filters another set of rows, which gets passed to another relationship table, which gets filtered again, which passed to this product table, which filters again, which passed to this relationship table, which ultimately filters my reseller sales table. There's a lot going on there. In order to make this more efficient, if we denormalize the data, which just means we take each of the values on our one-to-many relationship and put them onto the product table so that I've just got two tables and one relationship between them, we're going to have a much more efficient query. So I just filter this one table, my dim product, that goes to my relationship table, and that filters my my sales table. So let's talk about some various data architectures that can be implemented out there. So traditionally, one big table is what's used. If you go back, well, they still exist, but ever since learning about tabular models and tools like Power BI and Power Pivot, I have largely been encouraging my analysts to use star schema dimensions versus one big table. And they push back on me quite often, and that's okay because they know the patterns that they're used to. They know how to do the analytics in that use case. But it's not the most efficient, and there are definitely some drawbacks versus what Power BI expects. One big table is actually a lot more efficient for other tools. I'm thinking things like Tableau. A lot of machine learning algorithms expect you to feed one big table in. So don't get me wrong. Those are perfectly fine in certain use cases, just not Power BI. There's also normal models. So I'm thinking third normal form, Boyce-Codd normal form, fourth, fifth normal form, however many normal forms you actually want to go into there. These, again, are very useful, but they're more useful for transactional processing systems. Those are for inserting data quickly, updating data very quickly, hopefully not deleting data all that much. But if you store data like that, it makes those operations very quick. It's not great for aggregating. Filtering is actually pretty quick on a good normal model, but aggregation tends to be quite slow. This is actually very similar for the normalized data marts for the old Inman Corporate Information Factory model, where all your data is stored in third normal form. Again, in data warehousing, that is a very good type of model to use so that you have consistent data across the space. But when you push the data downstream into a semantic model like Power BI or analysis services, you want to denormalize those into star schemas. And it's exactly the same thing for data vault architectures. It serves a very, very good purpose. Data vault is great at storing historical data. I get the use case in there, but all of these require lots and lots of relationships. And like I said before, relationships tend to be an expensive operation when you're using the Vertipaq engine. So that brings us down to Kimball dimensional models or star schemas. They're simple, which is really good because a lot of the times you're building these models for folks that are not quite as sophisticated as many of us are when it comes to data architectures, writing SQL, building out those types of analytical models. They just want something where I can drag a measure on or drag a column on and get some answers to my information or to the questions that I'm asking. So these types of models are simple enough that my end users can understand it, and comprehensive enough that I can have multiple business processes that are described within one model. I'm also not the only one who says this. Microsoft, on their documentation for Power BI, explicitly says, understand the star schema and its importance for Power BI. They reference the original data warehousing toolkit by Ralph Kimball and Margie Ross. I know I've got a copy right over there somewhere. It's really, really useful at the semantic layer. So it really depends on what's the type of process that you're trying to do. Now, what is dimensional modeling, or how do we create star schemas? There's largely two different types of data. There is data that measures an event. These are what we call our fact tables. And there's data that describes an event. These are called our dimensions. Now, the way you want to think about these things is in general entities. An example that I have is a couple of years ago, I was working for a call center, and we were really interested in analyzing our agent statistics on a daily basis. So we would have a couple of different dimensions. The big ones would be each of the agents. So I have an entity being an agent. And then I would have maybe my days. There are other dimensions that were used, but those were the two main ones. So I need to know my time dimension, and I need to know my agent dimension. All the information that goes into describing a specific agent or date belongs in those dimension tables. So my person's first name, their last name, their employee number, their position. I could get other information like things like pay rates if I want to do cost analysis and things like that. And that would belong on the employee dimension. And then on my date dimension or my time dimension, I would have everything associated with a day. So the day, the year, the month number, so that I can sort my month. I would get some fiscal information. So fiscal month, fiscal year information. All that belongs on my dimension. And then all the ways that we end up measuring that specific agent's day would belong on the fact table in between. So how much time was that person logged in for? How many calls did they take? How many seconds were they on a call? And you could calculate things like how, on average, how long did it take them to complete a call? And there were a ton of other metrics that would end up getting used. So that's the basics of it. It's not that complicated to understand these types of models. There are some complexities down the road, but largely we don't have to worry about those when we're just learning this. There's also bridge tables if we need to traverse more complex relationships or more complex entities. I'm thinking things like if a product belongs to multiple product groups and I want to analyze my product group sales, you have to create bridge tables to say this product is in a couple of these groups, or if I filter that group, it gives me this set of products and things like that. Those are a little bit more complicated and kind of outside the scope of what we want to talk about right now. This is the basic example. It's dead simple. You have a fact table in the middle. You have various dimensions to describe those events, and then you have relationships between them. That's it. Kimball, when he first mentioned the design process, he said that you can do this in 4 steps. And understanding doing this in this order is actually a pretty important thing to do. You don't want to go identifying the ways that you're going to measure this before you declare the grain that you're going to capture your business process at. And more importantly, you need to select a specific business process. So I always follow these steps in order. All the information that's on the Kimball Group's old website. So the link is down there. But you just follow these in order, and it's very, very easy. So first, select a specific business process that you want to understand. Then declare the grain at which you're going to capture that business process. Most of the time, you can capture it at the most atomic detail. You can get down very, very nitty gritty. In that old call center example I was talking about, we actually had statistics down to the call segment. So a call would go into the system. That would be a segment. It would go into a queue. That would be a different segment. It would go in, be answered by an agent. That would be another segment. That might be too fine a grain for your use case. You might want to just simplify that a little bit for whatever your use case is. So make sure you declare explicitly the grain that you're going to capture your business process. Once you've done that, identify the dimensions. So figure out, how do I describe this business process? And then after that, lastly, identify the facts and the measurements that you need for doing analysis on that business process. Sometimes there's multiple fact tables with different grains that are involved. I've worked with financial companies where all the financial transactions are stored in one table. The grain on each of those tables is one row per transaction. And then another table would store all of our exchange rates. So one exchange rate per currency exchange per day. And that would be used in various measurements. So we could connect these tables, but if we store them separately, it allows us to do a little bit easier analysis on them. So let's use an explicit example here. We can use supply chain, and for my my model that I've got in here, I actually use the Wide World Importers database. It's actually a fantastic database for generating data that follows various patterns. I highly recommend it, and you can generate data. I've actually got this the database up on Azure right now, and it just runs a stored procedure every night and generates data for the previous day. Highly recommend it. Anyways, we have a business here. This is our Wide World Importers database, or our Wide World Importers business. That business has customers. Big thing about a business is that you got to make money. So in order to make money, we need to sell products to my customers. Well, if I don't manufacture my products out of whole cloth, I need to procure them from somewhere, either the raw materials in order to build the products, or the products themselves where I can just resell them. So I would have vendors who are sending me products. We can also, these things don't just happen. There's requests that go back and forth. So my customers send me a request for products, and then I send them the products. These are different business processes because I need to track that information separately. Same thing on the product, on the vendor side. I need to request products from my suppliers. And then lastly, none of this works unless you track the money. So this is a very basic use case from supply chain analytics. And you can see here, each one of those arrows represents a separate business process. I'm going to take this one as our example here. So it's me requesting products from my suppliers. If you look at the database, this is what a subset of those tables. This isn't even all the tables that I could have brought in here. We've got, let's get that laser pointer out here again. So down here, you've got the purchase orders, and we've got purchase order lines. So this is kind of your header detail pattern that's very common across a lot of transactional systems. The order line is associated with the stock items, basically our products. The order header is associated with our supplier. All of these end up getting associated with a people table because we've got an abstract concept of people in our system. So all of our customers and their contact information is stored in the same table that all of our employees' information gets stored in. We've got cities for where our suppliers are or where our people live. So you can see there's lots of complex relationships. And I'm not going to expect my analysts to be able to navigate this type of structure. They have other day jobs. They have things that they're trying to get done. It's up to me as basically, most of my job is in analytics architecture. It's up to me to build out structures for them to use. So let's take this and go through that 4-step dimensional design process. So I have selected the business process of purchase orders. I want to do analysis on purchase orders. The grain that I'm going to capture this at is I want 1 row per purchase order line. That's going to drive some of the decisions that I have to make. So anything that's on my purchase order header, that needs to be denormalized onto the purchase order line. Yes, we're duplicating data, and that's not a problem because of the underlying compression algorithms. Once we've done that, we can identify the dimensions. How do I describe this specific business event? I've done 4 dimensions in this case. So I've got an order date and all the date attributes that are associated with that. I've got an expected delivery date. When do I expect to receive my products? I've got a product table, and I've got a supplier table. So my products, my vendors, for what am I ordering and who am I ordering it from? That leads us to some of the facts and measurements that I would use to describe this process. How many products have I ordered? How many have I received? And then what's the expected cost, or what has the cost been for those products? So if I go and then actually show the model, you can see I've got a central model of purchase orders, and then all the dimensions on the outside: order date, suppliers, stock items, expected delivery date. And then I've got a couple of measures that I'm going to use, and I've got more in the actual model here, but I'm counting my orders, and I've got expected costs and some products that I'm going to receive. So let me just flip over to that model here. I'm just going to quickly go into the data pieces here. I just refreshed this data set. So my purchase order I've got 36,500 rows. So it's a relatively small table for analytical purposes, but you can see it's reasonably wide. I think there's 16 or 17 columns in here. My date, this is a small table that's only got 1,000 rows. My stock items got 227 rows, but this is pretty wide in this case. I've also got lots of string values in here. And same thing on the supplier side. I've got various suppliers and string values in here. Each of these would actually take up a lot of space. So one of the tools that I definitely recommend using at various points is a tool called DAX Studio. There's an external tool that you can use. I just want to show how this data gets compressed. So I'm just going to click on DAX Studio here. And importantly, let's just quickly go back to that purchase order. I have, there's 36,000 rows in here. If I were to look at the actual underlying data set, there's lots of whole numbers in here. There's some date information, some Boolean values, and a couple of string values, but not that many. If I were to go in and actually look at these in an uncompressed format, 36,000 rows, I did the calculation earlier. There's roughly 75 bytes of data per row. If you do the math, it's a little bit over 2 megabytes as a footprint. But my underlying file for this is 800 kilobytes. And if you go into DAX Studio, one of the really nice features that I like is in the advanced features here, you can view metrics. So you can see it's loading my metrics. And if I look at the summary, oh my, why is that? This is only supposed to be about 100. I don't think that's right for some reason. There's no way my suppliers table is 22 megabytes when it's only got 13 rows. So I'm not sure what's going on there, but we'll chalk that up to the demo gods, right? all I really wanted to say was, if you look at this purchase orders table, it's got 36,000 rows, and here are all the sizes of the rows. There's probably something going on with the supplier reference, actually, that's causing the size here. But the purchase order line, that's got the most distinct values in it, and it only takes up 219,000 bits of data. Is that bits? Might be bytes. I'd have to double check the the documentation, but I'm pretty sure it's 219,000 bytes of data. But there's 36,000, and each one of those values is more than 1 byte, so quite a bit more than one byte. So it should be able to take up a lot more than that. This is that value encoding that's taking place. And then there's, because purchase order line IDs is distinct for every row, there is no run length encoding that happens on that one. Anyways, I just wanted to show some of the compression that's in there. Again, I don't know why this is showing 31 megs. I did this earlier and it was 1.8 megabytes. So let's just say it's supposed to be that size. On to some of the visual techniques that we use. There was a talk given by, what was his name? Wayne Eckerson, I believe. This is going back 10 or 15 years ago for TDWI, which at that time was the Data Warehousing Institute. Now it's Transporting Data with Intent or Intelligence, I believe. He gave a talk about how to structure your reports. He came up with this idea called the MAD framework. All it was is that you have a layer for doing monitoring, you want a layer for doing analysis, and you want a layer for doing details. And in the original talk, what was spoken about is that, you really just want your executives doing monitoring. You just want middle management, maybe some analysts doing that analyze layer, and then your employees might be interested in their detail level analysis. I'm not necessarily a big fan of structuring it and saying that only this layer of management can look at that framework. It's more understanding what each of these layers is for. So I've kind of taken this and transitioned it into knowing what's in there. So let's look at, here's what's current. That's my monitor layer. What happened? That's in the analysis layer. So you can see some trends over time or by grouping. You can do some very complex things using the data analysis expression language. But you want to see largely what's trending when you're doing analysis in this regard. And then the detail layer, in my opinion, is all about proving your other two layers. It doesn't matter what the individual details are. It's that I can trust that my aggregations are happening correctly. That's really the big reason you want to use details, or you want to expose some details to your end users. So I'm just going to go to my Power BI report here, and I just want to quickly show what is on here. So these are my recent purchase orders. We can see, is this 1 day? Maybe I can just do that. No, I don't have anything in the last day, so I have to have this at 2 days. This is really useful because it allows me as an end user, regardless of the layer of management that I'm at, to go in and say, what happened yesterday, or what has happened since the last time I refreshed this model. They could be largely real-time analytics, but in this case, this is just what happened yesterday. And most of the time that's good enough for doing a lot of analytical purposes. I can see who my suppliers are, what are the categories that I have ordered. I can see who my supplier names are. There's my litware. This is the biggest one. I've got information about where my products are coming from. I've got an expected cost. I've got month-to-date analytics. I've got year-to-date. So I can see how some of those trends are forming. I've also got access to the individual purchase orders here. So that's kind of starting to get down to those detail level questions. This is where it's really important to start enabling your end users to drill from one report to another. I've created a report page in here called purchase order. This is just for viewing individual purchase orders. And you can see, right, see if this will allow me to zoom. There we go. Right here, I've placed purchase order ID into the drill through area so that anywhere I use the purchase order ID, my end users can go through and actually drill into this report and get context. So as an example here, if I'm interested in, there's a $21,000 order. What's going on there? Right click, drill through, purchase orders, get some answers to the questions that I have. Who did I order from? What's my payment days? What's contact information? All the information around what was actually ordered. And you can see when you do this type, when you structure report in this type of way, it allows your end user to say, okay, I know exactly what was on that purchase order, and I trust the aggregating number that you showed me before. So you can see there's $21,000 there. If I go back here, $21,000 being shown right there. That's the important part for being able to drill between these layers. So this is the monitor layer that I was talking about. It's recent, it's what's important right now, and it allows me to drill through to my details. Next one would be an analysis layer. Right here, I have all the purchase orders that are within this model. So I think this goes back to 2019, and I think here, let's take it to today. What is today? 12th? There we go. So I can see here's how my orders have taken place over the course of time. I'm comparing it to the prior year. I've got information associated with, where that data was coming from or where my products are coming from, some supplier and category names. I've combined those two tables from before, and I've got various KPIs being shown to my end users. I can also enable them to actually drill through and get a similar view to what I've got here. So here's my recent purchase orders. But if I say drill down to, maybe I'm interested in what's going on back in March. I can right click on this value. I'm going to drill down into that March. You can see how values or how purchases were ordered over the course of time in there. And here I can say, okay, well, here's some information or an expensive day. Let's figure out what was going on here. I can drill through to that day's purchase orders. You can see I've got March 16th here, and this is the exact same view as what was on that recent purchase orders, just in that given context. And I could drill through from here and get information about that specific purchase order. And I'm able to go back and understand how my data set makes sense to the end users. And again, this is a very simple example. I've only got one fact table in here and 3 dimensions. So simple example, you could have lots more data in here and create much more functionality. But this is a really good baseline for how you can structure a useful report. Again, this isn't pretty by any means, but it's useful to my end users to be able to navigate the data set that they're interested in. So a couple of other things I want to talk about is how to make my data consistent for the rest of the organization. So let's talk a little bit about color theory. How do we make it so that a report looks good to my end users? And the main advice I have for you, especially if you're like me and not a designer by any way, shape, or form, don't reinvent the wheel. Don't go picking colors by random and figuring things out. Go to your marketing department, ask them for the primary color palette, or go to your website and there's a little tool in there. You can go into the developer tools and look at various colors that are used on your organization's website. Just go grab the color and use it from there. So for me, my primary color palette is this one right here, that 316094. And I've got a couple of secondary color palettes in there. This orange one is largely important. And I like to use a really nice tool called Peloton. Again, I'll toss this into the chat here. And I apologize. I've been going on for what, 40, almost 50 minutes here. Were there any questions that that came through that I didn't pause for, Bob?
No, I have not seen any, actually.
Okay,
So I think
perfect.
we're good. Yep.
All right. So I'm just going to quickly run over to Peloton, and I'll toss this link into the chat here. You don't have to know much about color theory. The big things are put your primary color in here, pick a model. I like to use this triadic with complement. All it does is gives me a way of changing some of these colors in here, and then it gives the color that's directly across from my primary color. And then all you do is figure out okay, so say I need a green color because I like using some primary indicator colors in my model. All you do is you take this distance and you make it an even divisor of 360. So there's my green that I'm going to use, that 68C536. Same thing for yellow. I'm going to move this over here. Maybe I need to make that another 60. There's the yellow color that I'm going to use. And then this is a pink. I don't quite want pink as my danger indicator, so I'm going to move that over a little bit. This is probably going to be closer to a 45 right there, the E3513E. There's the colors that I'm going to use. The rest are going to be from my my corporate color pack, and I'm good to go. Within Power BI, all you do is go to View, click in here where it says Themes, and you can say Customize Current Theme, and you just change the colors in here. So I've got some colors in there. I've got this green color. There's a yellow color. That all their the big thing is that they're all based off of your primary color, and those ones will go relatively well. They'll be good enough for most purposes. Unless your marketing department comes to you and says you must use these specific colors, in which case just go with them because they're going to be consistent colors across the organization. So it makes it nice and simple for your organization to use. And I've just got couple of those screenshots just to show folks here. So here's that blue that I ended up using. I changed some of these distances to 60 in there, and then in order to get my red and my green, I changed that distance to 120 and gave me these two. So that's how I ended up with those colors. The last thing I want to talk about today is which visual should I use in which circumstance. And for this, a couple of my employees actually did a catalog of what's available within Power BI. They wrote a wonderful, wonderful blog on this. So I'll toss the link in the chat in a little bit here. But really what it is, it's the complete interactive Power BI visualization guide. And they've put all of this into Power BI. So this is a Power BI report that's on our website that, can be used, and it goes through all of the underlying, I don't want to go back. There we go. It goes through all of the underlying visuals that are in Power BI, when to use them, why do I want to use those specific ones. And personally, I have used this frequently to describe why I want to do a specific thing. So for example, I'm just going to quickly cover, what do I got? 4 minutes. I've got 3 that I'm going to cover just to describe what you actually want to do here. So let's talk about a stacked bar chart. Most of the bar charts are very similar in this way, but what you're trying to do is that you're separating categories. This is very different from a line chart, which is what I'm going to talk about next. So you have distinct categories, and what's nice about this is I have distinct boxes for each of those categories in my bar chart. And they could be vertical bars, they could be horizontal bars, they could be stacked or side by side. It doesn't really matter in that regard. And there's some really good definitions for when to use which of those. But in this case, you're largely just looking at categories. If I'm looking at a line chart, the big thing I'm looking at is time. And the reason you want to use a line chart for time is that I am implicitly saying that there is a connection between one data point and another. There's a line between them, so there is a connection. And that's what you're essentially saying when you use a line chart. It's not always the case when you're using a bar chart or a column chart. They're not necessarily linked, and you want to make that specific distinction. And then the last thing I want to talk about is, should I ever use a pie chart? And largely the answer is no, unless you have a small number of categories and they have largely similar distributions. Personally, I don't like them, and the reason is because they take up too much space. I have a book back here called Informational Dashboard Design by Stephen Few. That came out like 15 years ago, but it still has really good information regarding when to use what visuals. A lot of that filters down to information is hard to digest, so make it as easy as possible for me to understand. That's really all this boils down to. Now, I think I'm at, I've got 5 minutes left for any questions that folks might have, so I'm probably just going to stop it right there. I could go through other visuals, but let's save that for you guys to explore if you're interested in other types of visualization. So I will just end that. And I will take any questions that folks have.